right, let's get started. This is the agenda for the webinar. We will talk about our skin, the hazards, potential exposures, and skin notations. We'll also discuss the dermal sampling solutions that SKC has available and some applications and studies that has been done with our dermal products. We're going to end up talking a little bit about risk assessments for dermal exposures. All right, we will start with a knowledge contest type question. What is the largest organ in the human body? Many people think it's the liver. Yeah, it is true from an internal organ standpoint. However, it is our skin, the largest organ in the body in general. It covers our whole body, and we need to take good care of it since this protects our organs, bones, and other parts of our body. A little bit of biology here. Our skin accounts for more than 60% of our body mass. It is an important organ because it provides us with protection, water preservation, shock absorption, tactile sensation, calorie reservation, vitamin D synthesis, temperature control, lubrication, and waterproofing. We're not going in detail with the structure of the epidermis, but this diagram gives you an idea of how complex is our skin from the inside. Our skin is exposed to many agents. According to the U.S. Bureau of Labor Statistics, skin diseases or disorders are illnesses involving the worker's skin that are caused by work exposure to different agents. Examples are like contact dermatitis, eczema, rash, and some of the ones that you see here on the slide. Skin exposure in the workplace is a significant problem in the United States. Both the number of cases and the rate of skin disorders exceed the recordable respiratory conditions. This is the data from the Bureau of Labor Statistics in the United States. It represents the rate of injuries and illnesses per 10,000 full-time workers. As you can see, the rate of inhalation exposures have been decreasing, which is the green line, compared to the dermal exposures which have increased. That's the blue line over there. This may be because exposure assessments in the workplace usually start with air sampling for vapors and particulates, and controls are being implemented for airborne exposures. Surface contamination and dermal contamination are often the last considerations, even though more than 60% of the regulated chemicals carry a skin notation. All right, these are the occupations that are according to the Occupational Safety and Health Administration, OSHA, has been identified as risk for dermal exposures. As you can see, it covers different types of industries. However, any of us is at risk, not only in our workplace, but also in our personal lives. All right, there are the skin hazards that can cause problems to our skin. This includes biological agents, which include parasites, microorganisms, plants, and others. Physical agents, such as extreme temperatures, like hot or cold, and radiation, like ultraviolet or solar radiation. Mechanical trauma includes friction, pressure, abrasions, lacerations, and contusions, such as scrapes, cuts, and bruises. Chemical agents, which are the main cause of occupational skin diseases and disorders. These agents are divided into two types: primary irritants and sensitizers. Primary or direct irritants act directly on the skin through chemical reactions. Sensitizers may not cause immediate skin reactions, but repeated exposure can result in allergic reactions. It can also be a mixture of all these components that could have great damage to our skin. A worker's skin may be exposed to hazardous chemicals through skin contact with contaminated surfaces, deposition of aerosols, immersion, or splashes. This webinar will focus on products that will assess the chemical hazards, since these chemicals can go through the skin by means of thermal absorption. Speaking of thermal exposure, let's review again some biology terms in here. Thermal absorption is the transport of a chemical from the outer surface of the skin, both into the skin and into the body. Studies show that absorption of chemicals through the skin can occur without being noticed by the worker, and in some cases may represent the most significant exposure pathway. There are three ways that chemicals can be absorbed through the skin, and I'm going to go quick through these three, as you can see on the slide. We have the intercellular lipid pathway, which the chemicals can penetrate through these lipophil intercellular spaces through diffusion. We have also transcellular permeation, where the chemical is directly diffused into the skin. And then last but not least, we have through the appendages, is the diffusion of chemicals into and through the skin, through the hair follicles, glands, things like that. This pathway is usually insignificant just because the surface area of the appendages is very small compared to the total skin area. However, very slowly permeating chemicals may employ this pathway during the initial stage of absorption. Many commonly used chemicals in a workplace could potentially result in systemic toxicity if they penetrate through the skin. Some examples are pesticides and organic solvents. These chemicals enter the bloodstream and cause health problems away from the site of entry. Based on toxicological information and how the chemicals are absorbed in the skin, as explained before, organizations such as the OSHA and the American Conference of Governmental Industrial Hygienists, or ACGIH, and the National Institute of Occupational Safety and Health, NIOSH, put skin notation demarcations on chemicals that can affect us through dermal exposure. Each entity has their definition and process on how these notations are demarcated, but overall it's the same principle. You can see here there's similar terms, and these are underlined in this slide. We have magnitude of dermal exposure, potential significant contribution, and potential contribution. According to the ACGIH, the use of a skin notation is intended to alert us that air sampling alone is insufficient to quantify exposure accurately, and that measures to prevent significant dermal absorptions may be required. So it's very important to notice this. And these are some examples of some chemicals that have skin notations. You can see here that some of the chemicals have a skin notation in one organization, and others have skin notations of all of them. For example, aniline has a skin notation from OSHA, ACGIH, and NIOSH, and toluene diisocyanate, or TDI, has only one from ACGIH. But nevertheless, if it has one or more skin notation, we still need to address it in the workplace. We're gonna switch gears a little bit here. Now we're gonna talk about the good stuff, the products that we have that will assess dermal exposures in the workplace. Before we do that, many of you are wondering, oh wait, these products have a different name. Yes, these were from Colorimetric Laboratories Inc., better known as CLI. You may be wondering what happened. Well, Tom Klinger, who was the owner of CLI, with years of colorimetric chemistry experience, started CLI in 1992. His company led the field in the development and manufacture of these industry-leading products to address dermal concerns. SKC realized the importance of dermal hazards and are fortunate to be able to add this product line upon Tom's retirement in July 2019. Last year was a very busy year with this new acquisition. Learning the product line, moving the chemicals and equipment to our site here in PA. It was a challenge, but it was rewarding as well. We think it's a great decision. These are fantastic products that can be used to assess dermal exposures and surface contamination. We are very proud of this product line. These are the chemicals that can be detected using our dermal and surface products. It can detect aromatic amines, aliphatic amines, aromatic and aliphatic isocyanates, acid, bases, and phenols. The first 4 chemical groups are related mainly to the polyurethane industry. This graph is a summary of those chemical groups characteristics, and I'm just gonna review them real quick here. We have the aromatic and aliphatic amines, and that's the description. It's basically for aromatic. If you see the word aromatic, it's because it has a benzyl group in their molecular structure. In this case, also has an amine group. And those are examples of aromatic amines. We got the MOCA, MDA, some aniline, etc. And those are the uses. As I said, it's used in polyurethanes, in pharmaceuticals, and dyes. The aliphatic amines, it has an amine group. The only difference is if you see aliphatic, it's because it doesn't have that benzyl group in their molecular structure. So those are the examples of them, and also the uses. For isocyanates, same principle as the aromatic and aliphatic. For aromatic, it has that benzyl group, the aromatic ring, but also has an NCO group attached to it. That's what makes it aromatic. And the examples is TDI, MDI, and NDI. And it's typically used for polyurethanes, coatings, elastomer foams, and insulation. The aliphatic, as I said, doesn't have that benzyl group, but has the NCO. And some of the examples is HDI, HDMI, and IPDI. And then the uses are sealants, coatings, adhesives, and also elastomers. The acid and bases, I mean, as you can recall from science or chemistry 101, it's just chemical species that donates protons or hydrogen ions. And those are some examples, and those are the uses. And phenols, it's just the chemical compounds that has the hydroxyl group bonded to an aromatic hydrocarbon group. And those are the examples and the uses. Okay, now we will discuss the products that can be detected for those chemicals that I described previously. There are 5 types of products. You will find the surface wipe, the skin swipe, the PermeaTech, the DTAM, and the decontamination surface solution. So in the future slides, I will talk about each of them. As you probably noticed, we keep the trade names of the CLI products. Now we talk about the SKC thermal sampling solution. We still keep the CLI just because of the trade name of it. Okay, let's start with the SKC surface wipe. This is a very easy product to use. This is a qualitative analysis, and you can have the results in 3 minutes. And you can use it on almost any surface. And it's basically you spray the solution into the surface, and then you wait 30 seconds. After you wait 30 seconds, it's because of the developing process, you will swipe it. The developing solution, you will swipe it with a swipe, and then you will check the color after 3 minutes. If you see a color change in that swipe, that means there was that chemical in the surface. So again, you have the developing solution, you spray it on the surface, you wait 30 seconds, and then you go the swipe, you pass it through that surface, and then you wait 3 minutes, and then you see if you get a color change or not. For this type of products, there's a specific color change for the analyte. So in this slide, you can see the chemical group and the color change. So if it's a mocha MDA, it's kind of red-orange. Those are for aromatic amines. So there's depends on the amine, it changes different colors. The aromatic aliphatic isos, it's red on orange. For the aliphatic amines, it's a pinkish, like a fuchsia. And then the other ones, acid bases and phenols. So whenever you receive the product and you're going to use it, you will find the instructions as a reminder of what color you will see. And also in that slide, you will see all of the products related to surface swipe. The kits for all of the chemical groups, you will see the replacement surface swipe indicators in case you need them, and then the replacement cleaning developing solution. You will find more information on those documents that I said in the beginning that you can download on the WebEx box. Okay, the SKC skin swipe. Difference from the surface swipe, the skin swipe, of course, is for the skin. It's safe to use on the skin. It's a qualitative analysis again, and it's pretty much, the procedure is as follows. You take the swipe and you apply it to the skin, okay? And then you will put that swipe into a cup that has the developing solution. And then it's important that you put that swipe correctly. You will see that the swipe has this area right here. You will put it away of the developing solution, because what it does, this is the developing solution, it will go up into this area, and this is the area that it's gonna change. So it draws up, okay? That's the way that you do it. You don't need to spray the developing solution on the person. That doesn't work that way. It's just applying the swipe on the skin, you put in a developing solution, and if there's anything on that person's skin, it will show on this indicator right here. Very easy to use. As I said, it's safe in the skin. Similar to the surface, there's also, depends on the chemical group, it will change specific color. And those are the same color changes. And also these are the kits with all the chemical groups and then all the parts, the replacement parts that you may need. We got PermeaTech, and this is a little bit interesting because you know that chemicals can permeate protective clothing, especially gloves that are subject to repeated flexing, stretching, pressure, and abrasion. Variations in chemical resistance and work with chemical mixtures can make selecting protective equipment difficult. The PermeaTech sensors are like small adhesive bandages with a pad, which is the sensor, that is on the outside of the skin in contact with the glove, and that's important to notice. So basically, you affix the PermeaTech sensors to the thumb, the middle finger, and palm on the outside of the glove currently being worn. These areas are typically represent the highest degree of contact with an abrasion. Like if you have your hand, so it's either the thumb, the middle finger, or the palm. And then place the glove to be evaluated over the first glove. That's important. And then after 1 hour, remove the outside glove and the underlying PermeaTech sensor. If no breakthrough is indicated, apply a fresh PermeaTech sensor and continue to wear the outside glove for another hour. So this is like hour intervals. And after the extra hour, check again if the breakthrough occurred. The color change shows when and where a breakthrough occurs. This is great for the selection of gloves and to determine the user's safe time period for gloves. During initial evaluation of a new glove as a safety precaution, the employee should wear double gloves. The PermeaTech sensor should be outside of the glove currently in use and don the new glove over the first. You need to check the sensors hourly, as I said, to determine whether breakthrough occurs, and then change gloves accordingly. So this is a very interesting product to use whenever you're checking for breakthroughs on the gloves. All right, this is the product line of the PermeaTech. There's a different PermeaTech for each of the chemical group, and also that's the color change for each specific group. Also, we have PermeaTech for solvents, and these have a special charcoal that is included that you can send it to the lab for GC analysis. So it's kind of cool to have that in there. Okay, we got SKC DTAM. This is an excellent product to have available in the work areas. It is a polyglycol-based product and can remove many chemicals like aromatic amines, isocyanates, urethanes, pesticides, phenols, and others. Coming from a polyurethane industry, I must say that this product is great for cleaning the skin after contact with isocyanates and urethanes. We have two types. These are DTAM Skin Cleanser and DTAM Gold. So how it should be used? Okay, you don't need to wet the skin. So you're gonna apply the DTAM directly to the contaminated skin. And then you're gonna rub gently to work up like a white lather. And then you're gonna rinse thoroughly with lukewarm water and then pat dry. And then retest with the appropriate skin swipe to verify decontamination is complete. If you see that there's still that chemical based on the swipe testing, then you repeat the test accordingly. DTAM is most effective in reducing skin absorption when used promptly after chemical exposure occurs. And this graph will explain the difference between the DTAM Skin Cleanser and the DTAM Gold. The DTAM products cover a broad spectrum of chemical solubilities ranging from highly oil soluble, which is lipophilic chemicals, to semi-polar compounds that are somewhat soluble in water. This is the chart here shows the log KOW, which is the partition coefficient of chemicals. In other words, it determines how soluble or insoluble, like lipophilic, is with water. The higher the number, the more lipophilic the chemical is. The lower the number, the more soluble with water it is. This is good to identify what to use when an employee had a skin contact with a certain chemical. For those chemicals that have a log KOW from 0 to 2.5, soap and water will be sufficient. For those chemicals that have a range from like 3 to 3.5, soap and water will not be efficient. DTAM Skin Cleanser will work on those. For those chemicals that have a 3.5 or higher, they need a stronger DTAM, which is the DTAM Gold. So I hope that explains this graph here. And it's kind of cool because, like, for example, if you got a contact with phenol, based on this chart, DTAM Skin Cleanser will work. For example, if you get a contact with MDI in your skin, it will be DTAM Gold that you need to use to remove that from your skin. This is a study that we have that compared the ability of water, 50% soap, water, corn oil, and polyglycol-based cleanser to minimize the absorption of the isocyanates into the skin. So this paper, it's available online. Anyway, MDI is an isocyanate with a low vapor pressure, which means that the probability of becoming airborne is low compared to other isocyanates, unless it is heated, like well above approximately 100 degrees Fahrenheit, or sprayed or aerosolized, in other words. Because of its characteristics, this isocyanate like to stay in surfaces, including the skin. That's one of the main reasons they use MDI in this study. The data show that corn oil, which is the control, and DTAM, the polyglycol-based cleanser, are more effective than water or soap and water in limiting the transfer of MDI into the skin. That is the magic of science right here. So that's why these are very good products, the DTAM. The other set of products that we have is the decontamination surface solutions. These can be used to clean up a surface once a contamination is detected with a surface swipe. This is important in reducing dermal exposures in a work environment. If the surfaces are not cleaned up properly, the contaminant can be transferred to many places, including the lunchroom, doorknobs, tools, everywhere. At this time, these are only available for aromatic amines and isocyanates, both aromatic and aliphatic. You may use these products to clean up after a spill. However, make sure that you remove the spill amine or isocyanate from the surface as much as you can before applying these products. This is to avoid any chemical reactions during the cleanup. You also need to wear appropriate personal protective equipment based on the spill material. In general, the way to apply these products are as follows. First, you wet the area thoroughly with the decontamination solution. You can use an abrasive pad if necessary to enhance penetration. Then you allow the solution to react for at least 5 minutes and then rinse with water. You can recheck that area with a surface swipe and the corresponding developing solution to verify the contamination is complete. If contamination is still present, then you have to repeat the process. You may wonder if we can use this to decontaminate tools. Yes, you can. You have to soak the tool with the decontamination solution for at least 5 minutes and then rinse it with water. And then you can recheck with the surface wipe to verify the contamination is complete. So these are all the products that are available. So what's in the future for these products at SKC? We're just working on it, and we are developing these products for more chemicals. We are currently working on validation studies, so data will be available in the near future, and then expand the brand for more applications. I mean, there's new things to come, and we're pretty excited what's in our plans for the near future for these products. Okay, now that we are familiar with the SKC dermal sampling solutions, let's put them into perspective from an application and study standpoint. This is the fun part. This is just an example here. Let's say that you are an occupational health and safety professional who works in a flexible polyurethane foam industry. There is an issue at the site's pour line where the foam is produced. The situation is that there are employees with skin irritation symptoms such as reddening, itching, and swelling in their hands. During your evaluation, you notice that the employees are wearing gloves, but still are getting the irritation symptoms. The earth sampling data is below the applicable occupational exposure limits. Then you ask yourself, what's going on? Well, there are a couple of things that you can you may do or think about. These are not in order though. For example, you can use the skin swipe to verify what type of chemical the employee had contact with. Let's say you know that they're using MDI to make the foam, so you can use the type of a skin swipe for it, just to detect it. And then you can use the Permeatech to evaluate any potential breakthrough on the gloves. Maybe the gloves that they have on the pool line are not appropriate for the application. Then you can evaluate the housekeeping practices and use the surface swipes in the lunchrooms, tools, equipment. The chemical may be everywhere and is causing skin reactions on employees. Once you detect the root cause of it, you may use the decontamination solution to clean the contaminated areas and then check afterwards. As part of the housekeeping and personal hygiene practices, the employee can use DTAM to clean their skin after contact with the chemical. As you can see, there are so many ways to assess situations like this. As a side note, this is just a hypothetical situation. I just wanted to show you how these products can be used in a work area where amines, isos, and phenols, etc. are used. Okay, this is a slide that shows a snapshot of OSHA's website in the aromatic isocyanate surface contamination sampling and evaluation techniques section. The SKC products are mentioned here as tools to evaluate skin and surface contamination. As you can see here in the wipe sampling for screening, the swipe kit is mentioned. And also in the other section, for monitoring inside protective equipment such as gloves and suits, the Permeatech are also mentioned. It's pretty cool. Okay, these are studies that were done using the Permeatech to determine glove breakthrough. In this case, are mostly for aliphatic amines, but they used the Permeatech to assess that breakthrough. So this work. For DTAM, these are also studies that were used for the DTAM. I just want to show you here that these are used in so many applications, the DTAM and also the swipes. That is pretty impressive. I'm going to go back here for a second. So this is just a computerized image analysis tool paper. This one is in the automotive refinishing industry. This is for the oriented strand board, and this is for footwear. So as you can see, these are applications that polyurethane materials were used, and they're also used the DTAM and swipes to make these research or experiments, just to make sure that they work, and also to assess the areas. And this is another one, spray foam. These papers, if you are a member of the AIHA or ACGIH or even the Taylor and Francis, you may be able to get access to these. But it's the point of this slide is to show you that it could be, these products can be used to assess different applications. All right, guys, we're almost done. I just want to talk with you about risk assessment. It's just a quick summary, because risk assessments are also applicable to dermal exposures. You determine the degree of the hazard associated with the material and the degree of the exposure. You basically do like the risk of a chemical splash. Any significant differences in work practices between employees, the use of gloves versus the hand tools, and then the use of shared tools, and then the cleaning frequency. So it's it's just to have like an open mind and have good eyes just to see what could be triggers of potential dermal exposures on a workplace. And then you can determine the potential of dermal exposure, which includes like frequency and duration of that skin contact, the amount of skin in contact with that chemical, what's the concentration of it, and the likely retention time of that material on the skin, and the potential for dermal absorption. That's why whenever they put that skin notation, that kind of help us assess which contaminants they need to be, evaluated and how. So thank you for NIOSH and OSHA and ACGIH for putting those together. So I hope this webinar was beneficial for you. Now, Doug, Linda, and I we're going to assess the questions that came. As I said before, if we don't answer your question, we'll send a sheet with the questions and answers to everyone who registered for the webinar. Before we start the questions, I just want you guys to thank you for your attention, and please just look at those social media, like we're in Facebook, LinkedIn, Twitter, YouTube. So check us there, because we put good information, not only for CLI products, but also for other products as well. All right, I'm gonna introduce Doug and Linda. Hi, guys.
Hello. Hi, Lucinette. This is Doug Dowis, and thank you very much for the nice presentation, and thank you everyone for attending the webinar today. So let's jump right into the questions. There are quite a few of them here. The first one is, do the swipes or sprays leave a residue that needs to be cleaned off after use, especially, for example, with respirators? Linda is head of the media department. I'll let you take care of that.
Yeah, it's possible there could be some residual of the cleaning and developing solution on the surface. After you perform your swipe, just wipe it up with a paper towel, maybe with a little soap and water, and that should take care of it. Even for a respirator, I think that could work.
Okay, very good. Another question, someone would like to confirm if DTAM can be used with hydrazine.
Yes, well, no, it can't. I mean, it can't, because its KOW is pretty low. So soap and water should be a fine combination to get rid of hydrazine on the skin.
Okay, thank you. Lucinette, a couple of questions here. They're related. For the areas of the chart showing which skin cleanser to use, in the light green and gold sections, should the next cleanser up be used? For example, DTAM gold instead of regular DTAM for chemicals in the light yellow area. In a related question, on the DTAM chart, can both DTAM and DTAM gold be used for chemicals that lie between DTAM and DTAM gold? And if so, does the order matter? Can you answer that, Lucinette?
Well, Linda will be the best to answer that.
Oh.
Yeah, I mean, that's a tough one, but I would guess if they're kind of smack in the middle, probably either or would work for that. If it's leaning a little bit closer toward the, the DCAM number there, but I think either one would work if you're smack in the middle there, at least be effective. But, that's something that we probably should do some more research on. And we hope to, get some, more science, some technical studies in that area.
Mm-hmm.
Okay, very good. Yeah, there's a lot of areas that need more research for this, and it's pretty exciting. So that's good. Another question here: with the decontamination surface solutions, do you have a concentration that you can mix into a gallon solution to use in a sprayer?
Well, no, we do not. You mean like I assume that they mean that do we sell a concentrate that they could mix with something else to give them
Or smaller
Yeah.
quantities?
I mean,
Yeah.
we do have larger quantities of decontamination solution with a sprayer. I don't have all the catalog numbers in front of me, but we do have that. We even have drums of decontamination solution, but definitely we have gallon jugs with the sprayer, but we don't, I guess we don't have like a concentrate that you would mix with something and then you'd have a larger quantity. I could ponder that a bit, but we do have gallon jugs of the decon that we could send, that we could sell to you with the sprayer.
Okay, thank you. Does SKC have dermal samples for VOCs, for example, xylene and toluene?
No, we do not at this time. We see the interest a lot in the Permeatex, and so the charcoal pad Permeatex, and so this is something that we're looking at. But at this point in time, no, we do not.
Okay, can the swipes be used for metal exposures such as beryllium?
No, we don't have a chemistry yet, but metals are being looked at, and beryllium is one. So again, this is going to be on the future list. I think Lucinette mentioned early on that, we moved this company just by the time it got here, it was in September. And so we've been spending a lot of time just learning the product line, learning the procedures, and now we're just starting to try to get ourselves into the research phase and also to characterize the products a little more as well as far as detection limits and things like that, because that question has come up here and there. So, but we don't have anything for beryllium now, but definitely let me know your name. And this is something we're looking at.
It's a great question.
Yeah, it is.
Very good. In keeping with the theme for the last couple of months, someone wrote in, do we have any wipes for testing viruses, bacteria, or fungus on surfaces?
No, not yet. We are discussing, well, nothing colorimetric, for example, but we are discussing some things which I haven't even had a chance to talk to Doug about yet, a possible swab for COVID analysis. So, but that would have to be sent off to a lab. It would not be, colorimetric or anything in nature like that.
All right. In a related question, is it possible to test surfaces to see if they have been disinfected with a sanitizer?
Yes. You mean, are they talking for COVID or?
With, the residual sanitizers.
Maybe the alcohol, Linda.
Okay, I guess, do you want to take, I'm not following the question exactly. You mean to test it, okay, so somebody would be sanitizing a surface and then
looking for residual.
Looking for residual of the sanitizer. Okay, the sanitizer usually is alcohol, would that be correct? So we do not have anything that would detect the presence of an alcohol at this point.
Oh, okay. Are there studies that have linked dermal results with biomonitoring?
Not that I'm aware of, Linda, unless you have seen something.
No, the only thing where we have seen links between surface, and I'm not sure if you exactly call it a link, but with MOCA monitoring, biomonitoring, there's a lot of people that are doing the urine analysis for that, and when they get a high urine number, they then will try to track it down with the swipes to figure out where, where it came from. And so that has been extremely helpful because, as Lucinette alluded to, when you have some of these compounds that like to settle onto surfaces, they tend to travel all over the place. For example, onto doorknobs and into lunchrooms and even into office areas. We had one example where an office person, they were doing just a urine sample as a, control, and it turns out that there was, she had a positive indication for mocha, and so they had to figure out where it was coming from and things like that. So I don't know if there's anything, where it's exactly related like that, but there's a lot of places where biomonitoring and dermal products can be used together to effectively, analyze an exposure.
Okay, very good. Do you know what concentration there needs to be for the swipes to detect the chemical?
Yeah, okay, so yeah, we've haven't completed all the work, but it's usually it's pretty low, like in the low microgram range. I can tell you for isocyanates, in particular, and aromatic amines, we're still finalizing the data, but it's in the 2 microgram range. It's very low. And some of the phenols that we're working with, again, very low levels, like closer to the 1 microgram range. So we haven't gotten to some of the other compounds yet, but color chemistry tends to be very sensitive, but it also does depend on the chemical. Each chemical is probably, especially when you get to amines, aliphatic amines, because there's so many different aliphatic amines with different structures attached to them, that I expect that the detection limits could vary for compound to compound. So our goal, we're hoping by the end of this year, or maybe sooner, is to have a table of detection limits for as many compounds that we can test, that give a positive response on each of the swipes. So that's part of our research program right now. So that's where we are.
Okay.
And Lucinette said that question would come, and she was right.
Okay, thank you. What is the shelf life on the swipes?
It is 1 year ambient temperatures. We're looking to see if we can extend that. That was a shelf life that was tested by Tom Klingner, the former president of CLI. And so we're hoping that we could maybe get some of them longer than that, because, we like to have things that stay on the shelf for a long period of time. So, but right now, 1 year at ambient.
Okay, very good. Thank you. A good question here. They've all been good, but have you looked at how these products can be used with the Skin Perm software that has been developed through the AIHA Dermal Committee for Risk Assessment?
Wow.
No, I have not. I became aware of that process through a course that I took, but no, we haven't really done any work in that area, I don't believe.
Definitely something that we'll want to look at, though.
Yes, that's an excellent question.
Yeah, it's a very good prompt. Another question. Once the 2 parts of isocyanate mixes have been mixed, reacted, and/or cured, does the surface swipe detect the chemicals? Lucinette?
You mean whenever they're using the decon?
Well, once the 2 parts of the isocyanate mixture have been mixed and cured, will it detect the chemicals? In other words, are there residuals after the reaction? I think that's what the question's asking.
Okay, well, if it's already cured, it shouldn't.
unless there's some residual on there, right?
Yes.
Okay.
Yeah, I don't know what all the products are, all the ingredients that are used to make every different thing. So I think that it's used to make, to look for some of the main ingredients like the actual TDI that was used, in the production of the polyurethane foam or MDI, and the same thing with all the rest of them. It depending on what the starting chemicals were or products were. I mean, if they match up with any of the chemistries that we have on our swipes, they could detect it. But our chemistries are pretty specific for each of the groups.
Okay. Okay. Another question here. Does your literature have information on false positives or interferences?
Yeah, the only one we know of at this point is with MDI specifically for MDI, that methylene dianiline could be a positive interference. So if you have MDA in the environment, it could give a positive. Other than that, there isn't a lot of interference data.
There's a related question here. Are there significant interferences? For example, would the presence of one aliphatic be an interference for another?
Well, yeah, I mean, you're not going to be able to distinguish between aliphatic isocyanates, okay? Now, let me just talk about the two isocyanate tapes. The aromatic tape aromatic isocyanate swipe is specific to just aromatic isocyanates. It will respond to all aromatic isocyanates. The isocyanate tape will respond to both aromatic and aliphatic isocyanates, and I believe that is listed in the instructions. If it isn't, then I will need to get that updated. But those are the only few things that we know about. I mean, so all of the isocyanates will interfere because it's a qualitative kind of thing. It's not,
Yeah, I was gonna say, like, this is just for qualitative analysis, so it's per the chemical group. So if you're using the aliphatic isocyanate, either the skin or the surface, it's gonna take the aliphatic isocyanate, not necessarily IPDI or HDI.
Now, I will say that another one of our research projects is to look to see if we can actually analyze the colorimetric swipe. And so we are starting in that area to look at that, and it's possible then that we might be able to distinguish, but I'm not even sure we could do that for sure, but it's possible, but no work yet.
Okay, an interesting question here in a different area. Are you working with the ACGIH in developing surface TLVs? There are a couple of surface TLVs or compounds with surface TLVs. Lucinette and Linda, do you want to say any more comments about that, quantifying?
Yeah, I mean, I'll take that. Well, we're not working with ACGIH, but we are aware of the two. I mean, I'm aware of just two surface levels that have been appointed, or two chemicals that have a surface level listed. And we are working on a chemistry right now for orthophthalaldehyde, and we hope to have that, out by, but I'm just going to say by the end of this year. Now we haven't looked. I haven't looked at I know what the other one is, but we haven't started on that one yet. We thought orthophthalaldehyde was pretty straightforward, and so we're working on that right now.
Okay, and just there are a couple of questions here related to other products and their that we don't currently have, but there are some opportunities there. So So please keep checking back as we develop new products in this product line. The last question, we're running out of time here. And I think this relates back to the disinfecting one. Can you test to detect bleach solutions on surfaces?
At this moment in time, no. But I can look through my notes to see if we have some chemistries that we might be able to do that with. But right at this moment in time, no.
Okay. Well, very good. I appreciate everybody's time here in Lucenette. Linda, did you have any other comments?
No, I just want to thank everybody also for attending the webinar. And if you guys have any chemicals that you would like us to explore, we would love to know about them. And because we're going to have a research program starting, and would like to help you with your situation. So that's all I would have to say. Thank you again for attending.
In my case, it's like, thank you everybody for the attention. As I said, I hope this information is helpful to assess surface and skin potential exposures. And if you have any questions, that's the email that you go to, and we'll address it as much as we can. So, yep, looking forward to see all your questions.
Very good. Thank you, everybody.
Yeah, thank you.
Enjoy the rest of your week.
Yep. Bye-bye.
Bye.